Greetings and welcome to the Introduction to Astronomy. In this week's Astronomy of Other Cultures, we continue our look at Muslim astronomy and we'll talk about al-Birjandi and look at his contributions to astronomy. So let's go ahead and get started. So what do we know about al-Birjandi? Well, we know that he lived until 1628. So as you see, we're getting closer to the era of the Renaissance in Europe. And that's going to start to tie back in as a lot of the work that has been done by these Muslim astronomers comes back to Europe in the Renaissance. And we're in the era of, say, Copernicus now. So he did work on astronomy as well as other subjects in Persia, and he worked at Samarkand. And you may remember this from previous discussions about our Muslim astronomers as the Ulugh Beg Observatory, which was the greatest and largest observatory of the time. Now, in terms of astronomy, he worked by writing commentaries, and a lot of his work was commentaries on earlier works, so starting with those and then improving on the work that had been done. And one of his works, the Sharh al-Tadhkirah, was a commentary on al-Tusi. Now, you may remember al-Tusi from a previous discussion, as well as giving us the Tusi-couple as a way of turning circular motion into linear motion. So he did a commentary there and actually did some refinements of models. Now, again, we are still stuck on geocentric models. As I said, we're getting toward the era of Copernicus, but Copernicus had not yet published his work at this point of putting the sun at the center. So everyone at this point, with very few, maybe a few rare exceptions, was working with a geocentric universe. And again, he worked with what was called the Tusi-couple, given to us by al-Tusi, which is a way to, again, eliminate the epicycles. One of the problems in the geocentric models was that you needed epicycles to account for the motion, and this was a way to actually eliminate those. And we can look at the Tusi-couple here as to how that works, and as this runs, we can see that we can take a circular motion, something moving in a circle, and form that from different linear motions. So we can get that circular motion, but we can see that the object moving, the ends of the object appear to move in two straight lines. So this was a way to be able to explain things like the epicycles without using an epicycle. And to many people, this was much more intuitive. Epicycles were starting to just seem wrong. It seemed odd that things were orbiting around nothing. Again, we're barely to Copernicus. We haven't gotten to people like Galileo or Newton yet in our understanding of gravity. But still, we're starting to get that this made more sense and was a better way to be able to explain the motions that we see. He did look at the Earth and consider the Earth as rotating, possibly that it could be rotating. So he didn't actually endorse this and say that, yes, the Earth rotates, but he actually considered that it could be rotating. And we're starting to see more and more of that as we've looked at the astronomers recently in this series. So considered as a serious possibility, but not necessarily the fact of how things moved, but that it could work just as well for explaining the motions. Interestingly, a lot of his works were translated into Sanskrit and then influenced Indian astronomy, as well as being translated into Latin and influencing the astronomy of the Renaissance in Europe. So let's go ahead and finish up with our summary, and what we've looked at today was al-Birjandi lived until the year 1524, known for his work on astronomy in Persia, and gave us refinements to various astronomical models, including the Tusi-couple, to show how we could explain retrograde motion without an epicycle. So that concludes this discussion on al-Birjandi. We'll be back again next week to talk about another astronomer of the Muslim world. So until then, have a great day, everyone, and I will see you in class.